Sorry. All right, so the last section in this unit, this long gargantuan unit, is modeling and solving equations with our natural base and our natural logarithm. So earlier in this unit, we did model using three particular formulas. General formula, y equals a times b to the x. Exponential growth, a parentheses 1 plus r raised to the t power. And exponential decay. Same formula, just a minus sign in the middle. So, depending on the scenario, dictated which formula you used, dictated how you solved it, so on and so forth. Same thing rule applies with the natural base. So exponential growth with a natural base uses that particular formula. A times e to the kt power. So a is the initial value, whatever you're starting with. T is the time in years. And k is your rate of continuous growth. So it's your growth rate. So if it's exponential decay, the only difference is that the k value is negative. Same formula, just a negative k value. So which one you would use depends on the scenario and the problem. If you're talking about something such as population growth, obviously it's growth, so you're going to use the first equation. If you're talking about exponential decay, then you're looking for something that's decreasing. So you're looking for something that's decreasing. Grab a seat that has paperwork on it, and get caught up because we're already moving. So, for our care and concern today, we're going to focus on two different scenarios. One being population growth. The other, well, population change, because it could theoretically go down. And the other being bank accounts. So most of you in here already have a bank account. All of us in here want that bank account to be bigger. But we'll look at essentially how most of the bank accounts you all have work. Some of those calculations that go with it. So, any questions either here or at home before we get into example one? Yeah, if you have questions, please feel free to ask us. Close mouths don't get fed. Oh, look at the pretty glasses. That's so sweet. All right, population change. In 2007, the population of the state of Georgia was 9.36 million people. In 2000, it was 8.8 million people. So determine the value of K, Georgia's relative rate of growth, and when will Georgia's population reach 12 million people? So they started out by giving us a figure in 2007 and a figure in 2000. So first thing that we can do is write this information as ordered pairs. So in 2007, you have 9.36 million people. So 2007, comma, 9.36. 2000, comma, 8.18. Now, anytime you are dealing with an actual year, I strongly suggest that you convert the year into something that's a little bit more user-friendly. You can use 2000 if you want to, if you're prepared to start working with ridiculously big numbers. So I'm going to change 2000 to the number 0. I'm going to change 2000 to the number 0. So I'm going to pretend as if I'm starting with the year 2000. So start at 2000. So grab a seat wherever there's paperwork. We're on example number 1. So instead of using 2000, we're going to use 0 to make the number smaller for us to work with. Which is that's fine, that's your right, you can do that. As long as you're consistent. So if you're going to be consistent with it, you also have to change 2007. So that's a quick asking yourself, well, how far is 2007 from the year 2000? 7 years. So these are the 2 points that we're going to use to solve our problem, to help us out with the problem. Any questions before we keep going? And those of you who are at home, again, if you have a question, don't hesitate, ask. It's going to be a lot easier for me, from my eyes, to look at the 10 people that are in the room. So if you have a question, make sure you ask. All right, so now we can starting to solve the problem. So they want us to find K, the rate of growth. So since they're talking about a rate of growth, we know what formula we have to use now. So y equals a e to the kt power. That's the formula we have to use. That's the formula we have to use. No, I hope you writing. I write, you write, especially since you're going to summer camp in a couple months. They will teach you about that writing down there. So the a value is our initial value. Since we changed that x value to 0, 8.8 now becomes the initial value. E will forever stay E. K is what we don't know. T, well, we started with the year 2000, we went to 2007. So that's 7 years. So your T value is 7. So the Y value is the value that you have after 7 years. $9.36. So we've taken our information, we plugged it into the formula. Any questions? Anyone stuck anywhere before we start solving it? Again, if you got a calculator, have it ready, because it tells me the number's not going to look all that nice. All right. So we plugged in what we had. Let's start solving it out. So we need the E by itself. So we need this part by itself so that we can do the rewrite that we did yesterday. So 8.8's got to go. 8.18's got to go. Divide it out. So 9.36 divided by 8.18 gives you 1.14425 and a whole bunch of numbers after it. So again, we're going to carry the 3 unless they tell us otherwise. That's 1.144 equals e to the 7k pi. Again, carry the 3 unless they tell you otherwise. So 1.144 equals e to the 7k. So we do a rewrite. Just like we did yesterday. There's our base. There's our exponent. There's our y value. So remember, e to the x equals y converts to natural log y equals x. So if we do our rewrite, natural log of 1.144 equals 7k. You don't have to put the e because it's understood. Go ahead.
Where do we find the natural log part in our calculator?
Natural log is next to the number 4, to the left of number 4.
All right.
So natural log 1.144 is 0.135. Divide both sides by 7. You get 0.019 equals k. So it's not a hard problem once you know where everything goes. Once you know where everything goes, then it's you go ahead and solve it out. That makes sense. Yeah. Side note, those of you who are here, make sure you throw your name on your paperwork in the event that you leave it. I know who to give it back to. But any questions at home or in here on part A before you do part B? All right, so part B. Fit this back into the screen. When will Georgia's population reach 12 million people? So we want to know when will it reach 12 million people. So that means we don't know the year. We want the y value to be 12. We're looking for what x value, what year will give us 12 for the y value. So let's go ahead and set it up. So for part B, we're still using the same starting equation. Still using that formula. The y value, they told us what they want it to be. 1 million. A is still the initial value. We started with 8.18. We keep using 8.18. E is still E. The K value we got in the previous problem, 0.019. This time we don't know the time. We don't know what T is. So we didn't use 7 and we didn't use 9.36 because that's specific to the year 2007. we're trying to figure out 12, so that's not going to be the same. Any questions before we continue? All right, let's keep it moving. So here's our equation. We solve for t, and we can use that to get the year. So just like the problem that we did before, this part, the e part has to be by itself before we can do a rewrite. So 8.18's got to go. So what are we going to do with 8.8? We divide that out. That drops. Let the calculator do a little bit of work. $1.467. So now that the E is by itself, we can go ahead and do the rewrite. We rewrite it using the formula from above. Here's our base. Here's our exponent. Here's our y value. So the rewrite becomes natural log 1.467 equals 0.019t. And then we're going to let our calculator do some work. 467. So 0.383. Then divide by 0.19. So you get 20.158 years. That's your time. So it's going to take, I'll lift it up, Andrew. So it'll take about 20, a little more than 20 years for this to happen. Any questions on how we solved it out? Not done. They asked for when. We just found out how many years it would take. They asked for when. 2020. So it would end up being somewhere in the year 2020. So you would take your years. So you take your starting year, which is 2000, and add your t value. So 20.158. So somewhere in the year 2020. So that's where most people make their mistake. They get the t value, forget to figure out what the year was. So get t, forget to figure out what the year was. So, be a little thorough before you finish it off. Any questions before we move on to looking at some bank accounts? Andrew, you sure don't want to calculate it? All right, so bank accounts. Most of you have bank accounts, right? Most of you wish you had more money in your bank account. Hopefully that would be a yes. So, there are two types of ways that your bank can earn interest. There's compound interest, in which you're earning interest certain times a year. And then there's continuously compound interest, which means you breathe, you making money. You blink, you making money. This is the kind of account that I want. Blink, make money. Sleep, make money. Fall down the stairs, make money. All the time, make money. So the compound interest one we used earlier this unit. A is your ending amount. P is what you start with. R is your interest rate. N is the number of times your interest is compounded. And of course, T is your time. With continuously compounded, P is still how much you're putting in. E is your E. R is your interest rate. T is your time. So there is no end value. There's no end value when it's continuously compounded. Well, Mr. Lowe, what do I know? How do I know when I'm going to use which one? Very, very simple to figure that out. The second you see the word continuously, that's the formula you're using, period. You see the word continuously, you use that formula. You see quarterly, monthly, semi-annually, weekly, daily, that formula right there. So continuously, that formula. Anything else, that formula. So you get the difference? So we're going to work with this one first. And then we'll do the compound interest one. Continuously compounded. All right, so part A. An investment account pays 4% interest, compounded monthly. $2,500 is invested in this account. What will be the balance after 15 years? So this is just a straightforward plug and chug style problem. So since they told us monthly, we go to the first formula. That's the formula we go directly to. So P value is 2,500. 1 plus, so 4%. Remember, you got to change that to a decimal. 0.04. N is the number of times it's being compounded. Since it's monthly, it's 12 months in a year. 12 times 15. So, any questions set up? Now this one I'll bring my computer calculator out because I'm going to throw it all in the calculator all at once.
So we just throw everything into the calculator?
We can throw everything into the calculator. The only thing we have to make sure is that we put it in the right way. Yeah. Once you show that setup, then I don't need to see anything else other than that answer. Now, if you need to break it up into parts so that everything works out, it is what it is. So we have 2,500, open parentheses, 1 plus 0.04 divided by 12, close parentheses, raised to the, now, I put my calculator in the older model. The newer model is just going to move the exponent up. The older model open the parentheses, 12 times 15. So everything should be in there correctly. That's what you should get. So $4,550.75. Again, I use the older style because the newer style is going to write it the way that you would normally write it. Older style is older, so you got to pay attention to a few extra things. 45, 50, 75. 45, 50, 75.
So we don't write the 4 at the end?
Let's see. So this is money. Money always goes in two decimal places. So the question was, do we take this to three decimal places? The answer is no. Money always goes. So money is always two decimal places. So money is always two decimal places. All right. Any questions before we continue? All right. We want to close a little room here for part B. Part B. Determine the amount of time it will take to quintuple. Determine the amount of time it will take to quintuple. So just in case you don't know what quintuple is, quintuple, 5 times. So triple would be 3. Quadruple is 4 times. Most of us know that double is twice. So quintuple is 5 times. So that means we are starting with $2,500. So we're starting with $2,500. That means you want your A value to be 25 times 5, $12,500. So they're asking you in this particular problem how much time it will take. So everything else is the same except for time. We don't know what the time is. So we're still using the same formula. A in this case is 12,500. The p-value is still 2,500. 1 plus 0.04 over 12. 12 times 2. This is the setup at the start of the equation. Everyone good with setup? Everyone at home good with setup? All right. So the first thing we're going to do is we're going to clean this up a little bit. We're going to work that part out first. We can put that in the calculator and take care of that. So 1 plus 0.04 divided by 12 is 1.003. So your exponent has the variable, which means this is an exponential equation. We're going to have to rewrite it. But we can't rewrite it until one of these numbers goes away. The 2,500. You can't multiply those because this has an exponent attached to it. So 2,500 has to go. Divide both sides by 2,500. So, questions before we continue? All right, then it's an exponential form. We do the rewrite. There's your base, there's your exponent, here's your y value. So since you do not have the e, this is now a standard logarithmic equation. So remember the standard log write up, e to the x equals y, goes back to log base b, y equals x. So this is now a standard rewrite. Go back to a standard rewrite. So this is log base 1.003 of 5 equals 12t. We have the rewrite. So now we use change of base formula to that part of the problem. So remember, change of base showed up quite a few times on the quiz that you submitted already. So change of base, you have log of 5 divided by log 1.003. Let the calculator do a little work. So you have 537.284. And then divide by 12. So if you want your money to get to 12,500, you're going to be waiting 44.774 years for that to happen. So you're waiting nearly 45 years to get to that number. Now, that's assuming that you don't put any money into that account. You take that 2,500 and you just let it sit there and that's it. Obviously, it'll get there quicker if you're putting money into it. Any questions? Part B. Again, it's not a hard problem. It is a problem as long as you know where everything's going to go. It's a pretty simple problem to work with. That you can see these type of problems, the calculator is going to get some work. So if you don't have a calculator, make sure one is readily available to you. Any questions before we do part C? For those of you all who have the notes page, the back part is blank in case you need to use additional space on it. Anyone still using part B, either at home or in here? Anyone using it in here? Okay. At home, speak now or keep your peace till later. All right. So for part C, how much money would need to be invested initially to reach $100,000 after 18 years? So I want to know how much is initially. So which one of these am I missing? P. Now I'm missing P. I know everything else but P. I know everything else but the initial amount. Yeah, I should be able to put it in. So, from that formula, we know everything but the p-value. We want to get $100,000. So that's your A value. You don't know what you're going to start with. 1 plus 0.04 over 12 raised to the 12 times 18. So this is our setup. Now, for my graphing calculator people, we're going to make this very easy on ourselves and get this done in 2 steps. Those of you with a scientific calculator, as long as you put everything in correctly, you should still also be able to get it done in 2 steps. So this is what we're going to do. First step. We're going to take all of that and put it in the calculator. Just that part, put it in the calculator. And we're going to figure out what that number is. So 1 plus 0.04 divided by 12 raised to the 12 times 18. Make sure I put everything in right. .05197. Match up. All right, so 2.052. So 100,000 equals 2.052 B. Well, that's simple. That's an easy equation. You don't need no log for that. Divide everything by 2.052. .052. So that means your initial investment has to be something in the neighborhood of $48,732.94. It's a pretty big investment. Someone got some Bitcoin and cashed it in and put it in a bank account. That would be me if I ever cashed my Bitcoin out. I bought 5 coins of it back in 2010. Look, it was only $5. I mean, I'd waste $25 going to the store. So if Bitcoin just fell off or did nothing, I'm not losing anything. I didn't know how much Bitcoin was worth until I just went on the computer and looked.
You go look like, oh, I have 250 grand now.
You say what?
You go and look and just, oh, I have 250 grand now.
Well, more like 320 grand, but no one's who's counting. So, any questions, A, B, or C? We'll use a little bit of time left to use the continuously formula. So yeah, that formula is not hard. It's more so a pain in the neck to use it. This is a little bit more straightforward. And it's a lot smaller. So, part D. We're still doing 4%. I'm still doing 2,500. We're still doing 15 years, but now we're going to compound it continuously. Same type of scenario, but for continuous. So we're doing the exact same scenario. So the second we see continuous, that's the equation we use, curve equation. So initial value is 2,500. E is E. R is 0.04 times 15. So it's a lot of plugging and chugging. You with the calculator do that. All this is the calculator problem, Let the calculator do its work. So we hit second. 1, 2, before you hit second. Put that out. 2,500. Second ln. 0.04 times 15. Close parentheses. Again, you can let the calculator do the entire thing. 45, 55, and 30 cents. $45, 55, and 30 cents. You good with D? Yeah.
How did you do that? Because I started talking about and then after that.
0.04 times 15.
Yeah, I did that. And then I got that. Oh, that's not the thank you.
If you did 0.4.
Well,
All right, so part E was just like part B, except we're now using a different formula. We're using a different formula. So determine the amount of time that is going to quintuple. So that means we still want $12,500 equals 2,500 E to the 0.04 T. Same type of problem, just with a different formula. So, let's make it work. This is the part that we need by itself. So 2,500's got to go. So 5 equals E to the 0.04 T. So now we're set up for a rewrite. There's your base. There's your exponent. There's your y. So natural log of 5 equals 0.04 t. Let the calculator do a little bit of work. Natural log of 5 is 1.609. And divide by 0.04. So 40.225 years. So you save yourself about 4 years. Doesn't really seem like that much, but you save yourself 4 years. That's how long it'll take. Any questions, part E? So again, a lot of this is letting the calculator do the work. Hopefully for those of you in here, it's a lot better than staring at the screen. All right, last one, part F. How much money would need to be invested to reach 100,000? So that means you know everything but the initial amount, just like the first problem. So 100K equals P E 0.04 times 18. So that part is calculator. Let the calculator take care of that. 0.04 times 18 is 2.054. Divide it out. $48,685.49. So you still need a lot of money. It doesn't really matter which way you choose to do it. Still gonna need some money to make it work. So again, when you're solving it in word problem format, the main thing is read it, figure out where everything goes. The solving part is actually the easy part. Hardest part is just knowing where everything goes. Any questions either here or at home before we get ready to close up shop?
Mm-hmm.